All right, well, welcome back to another section of Tech Math. Today we're going to be looking at section 5.4, which is multiplication of monomials. And so one of the things that we can do when we are working through multiplication is we can utilize the process of adding or including exponents in our pieces. So if you look specifically, let me go to our notes here. If we look specifically here at this top section, you'll notice that if we're multiplying things out multiple times, these variables, then what we're going to be doing is utilizing our exponents to indicate the number of times we do the multiplication, or the number of, I should say, the variables that we're multiplying. So we have an x times an x times an x. That's going to be raised to the third power. C times itself 4 times, also raised to the fourth power, or the power of 4. This right here, we call the c and the x, those are going to be our bases, okay? It's the base, it sits at the base of the exponent, and the superscript 3 and 4 are the exponents, okay? Here are some of the basic properties that we're going to be utilizing as we work through them. When we multiply, this should be multiplication. Totally screwed that one up. This should not be an addition sign. I will change the notes, but it's wrong here. So if you look at it on Canvas, this should be a to the m times a to the n. This is equal to a to the m plus n, okay? And I'll demonstrate that. Raising a power to a power means we multiply. And then if we have a product of something here, we can also raise that product, each individual piece inside that product, to that power as well, okay? And so what I'm going to do now is I'm going to walk through some of these examples. Let me go ahead and pull up the whiteboard here. All right. So, for example, in this section, let's go ahead and take a look at a few different questions. So question number 4. Suppose I've got 4x times 6x squared. So when we have a situation like this or a problem like this, the first thing that we need to do is we need to take the 6 and the 4 and multiply them together. So I'm going to rewrite them out like such. And then we've got our x and our x squared, okay? So this thing is going to work out to be 24, which is the first piece. And then the second piece here, I've got an x to the first. You can kind of think of it as an x to the first. If there's no exponent shown, you can think of it as a 1. It's implied. And so then what we're going to do here is we're going to add these exponents together. So this is going to be the same thing as x to the 1 plus 2, which in this case is going to work out to being a 24x to the third power. Okay? All right, question 8. Same kind of idea. 9y to the third power times a minus 4y to the fourth. Okay? All right, so on this one, we do the same thing. We're going to take our coefficients, which are the 9 and the minus 4, and we're going to multiply these guys together. And then we have our y cubed multiplying by our y to the fourth. This is all multiplication here, so we can just multiply straight across. And then what you notice is the 9 times the 4 is a 36, but I've got two negatives, and if it's a negative times a negative, that equals a positive. 36, not 34. 36, y to the 3 plus 4, which is equal to 36y to the 7th. Okay. And we can do this with more complicated problems too. So let's go ahead and take a look at another one. So this is question number 12. Again, these are questions right out of the back of the section. So if you want to go back and take a look at them, some of them actually do have some solutions. And so we'll go ahead and you can kind of click those open if you want. Take a peek. And here we're going to multiply by 6a squared b cubed. So this is a problem that we have kind of multiple exponents happening on different bases. But the process is pretty much the same. Again, everything is multiplying from left to right. And so that means that I can do the exact same thing. Minus 9 times 6. And I can write out my a's. A times a squared times b squared times b cubed. And now my 9 and my 6, I multiply those and slap a minus in front. So I believe that's 54, minus 54. And we're going to have our a to the 1 plus 2 here, b to the 2 plus 3. And so this whole thing works out to being minus 54, a to the 3, b to the 5. All right. So that's question number 12. Let's go ahead and do another one. This one's going to involve the use of fractions. And the one thing that I want to really make sure you're aware of is that when you multiply fractions, you're just multiplying straight across on the top. So the numerators multiply to the numerators, denominators multiply to the denominators, right across. Squared. And this is going to be 9/16 times x times y squared, okay? So in this case, when I simplify this, I'm going to have 2/3 times 9/16, which is equal to, or times, I should say. I need the x's and y's. Forgot those. X squared times x times y squared times y cubed. Or is that cubed? No, that's squared. So by the way, this is the same thing as 2 times 9 over 3 times 16, okay? And I'll have x to the 2 plus 1, y to the 2 plus 2. And here we get 18 divided by 48. X to the 3, y to the 4, okay? And you can actually reduce this down. I'm not going to go back and do all the reducing here, but one thing that you can recognize is that this is the same thing. There's a 6 that goes into both of these, okay? So a 6 goes into the 18, and then a 6 goes into the 48. So a 6 goes into 18 3 times, and I'm going into the 48, I believe, 8 times. And then we're going to be left with our x cubed y to the 4th. Okay. So that's how you go ahead and solve that kind of problem. All right, let's go ahead, keep moving. So this next one is number 25. And here I've got x cubed squared, okay? This is a different situation than what we had before, and the reason why is because we're taking something with an exponent and raising that also to an exponent. When we have a situation like this where we're taking something with an exponent and then we're raising it to another exponent, we're doing multiplication instead of addition. If you want, you can think of it like this. This is the same as x cubed times x cubed, right? There's 2 copies, which is where that exponent kind of goes in or fills in. It's 2 copies of that x cubed. And so we can treat this as though it's x to the 3 plus 3 here, which is equal to x to the 6th. But if we're adding the same number multiple times, that's the same thing as multiplication, okay? So another way of thinking about this is it's x to the 3 times 2. And in this case, this is our x to the 6th. So it's a little bit of a quicker way to get to the end without having to rewrite all of the intermediate pieces out. Question 30. Imagine I've got 5x squared raised to the 3rd power. So the thing is, this 3 has to apply to each piece, okay? We need to put it on the x squared. We also need to put it on the 5. So that means that we're going to have 5 to the 3rd times x squared to the 3rd. Okay. So this right here is going to be 125 x to the 2 times 3, which is equal to 125, x to the 6th. Okay. All right, let's do another one. On this one, there's a lot more going on. So we've got a minus 4 times a squared, b cubed, c to the 4th, all raised to the 4th power. And so we'll apply the 4 to the number in front. And if you have a negative, you got to make sure that you apply both the negative and the number, that you're not just slapping a negative on whatever the number is raised to that power. So bring the minus along for the ride on these. It's going to make life a lot easier for you. And then we've got the a to the 2 times 4. I'm just going to go ahead and write these out. 3 times 4. And then c to the 4 times 4. Okay. So this works out to being, this is a rather large number. I wouldn't expect anyone to actually know this off the top of their head, but this works out to being 256. And the reason why it's positive here is because I have 4 negatives that are multiplying. Okay, a negative times a negative times a negative times a negative. And because that's an even number of negatives, it pretty much eliminates itself. I can get rid of the negatives in its entirety. So this is going to be a to the 8th, b to the 12th, and then c to the 16th. And that is the solution for that problem. Or I guess the simplification would be the proper term. I should be using the proper term. Okay. Let's go ahead and jump to the next one. So on this question, we're going to let a equal 2, and we're going to let b equal minus 3. Okay. So in this case, I'm given this problem, 41 times a squared times minus 2b cubed. And what I need to do is I need to make sure that I'm substituting these particular pieces in right here, okay? So in other words, this is kind of what it looks like. I'm going to change these to kind of square brackets because I've got a lot of brackets going on. 41, the a is going to be a 2, so this is 2 squared, and we're multiplying it by a minus 2 times minus 3 cubed. Okay, there's quite a bit of stuff going on here. So it's all multiplication, so that's really nice, but let's go ahead and just take care of these exponents right off the bat. It's just going to make our lives a lot easier. So I'm going to leave this guy alone, 41. 2 squared is going to be 4, so this is multiplying by a 4. And then we're going to be doing our minus 2 times our minus 3 to the 3rd. It's not minus 3 times 3, it's minus 3 to the 3rd. So minus 3 times minus 3, which is a positive 9, times a negative 3, which is a negative 27. Okay. So now, as a result, you can kind of see we're going to get some rather large numbers here. And I'm going to change these actually to circular brackets. 41 times 4 is the same as 164. And we're going to multiply by a negative 2 times a negative 27, which is a positive 54 right here. And when you do the multiplication, you're going to get 8,856. Okay, rather large number going on with this problem. Actually, it's funny because the last problem I chose for this section, which is the next one, has an even larger number. I don't know why they like such big numbers. Anyway, let's go ahead and take a look at it. So we've got the same thing. A is equal to 2. B is going to equal minus 3. And this time I have to do it in 5a squared times b cubed squared. Okay, so let's go ahead and make these substitutions. I've got 5. Here, let's just put these all in parentheses. You can put as many parentheses as you want. Sometimes it just makes it a little bit trickier when you're dealing with a lot of stuff to just keep everything in line. So that's why I use brackets as much as I possibly can. So 5 times 2 squared times a minus 3 cubed, all raised to the second power. Okay, so let's start on the inside and work our way out, but we'll take care of the exponents first. So leave the 5. This is going to turn into a 4, which is just 2 squared. And we already knew from the previous one that this is going to be a minus 27 squared. So here we're going to get a negative 540, and we're squaring that thing. And if you multiply this whole thing out, I've just got negative 540 times itself times a negative 540. It's going to turn into a positive 291 600. And that right there is going to be my final answer in this problem. All right, well, that's all I have for today. If you have any questions, feel free to reach out, let me know, and hope you have a fantastic day.